Alright, so for lab today we're going to be looking at net primary productivity and gross primary productivity of algae in our lake. To do this, we're going to be, instead of measuring carbon like we've talked about in class, we're actually going to be measuring another product of photosynthesis, but a reactant in respiration. We're measuring oxygen using a dissolved oxygen kit. What we're going to try to do, since oxygen is a reactant for respiration and a product of photosynthesis, we can use the production of oxygen in light and dark conditions to estimate net primary productivity. We're going to we have 4 different flasks. Flask with the photosynthetic algae that's not wrapped up in aluminum foil, so that's exposed to sunlight, will release oxygen and will take up oxygen for respiration. We'll also have a flask with the algae water in it that's covered up, that's dark. And in the dark flask, the algae will only respire, thus decreasing the amount of oxygen available. So we'll have the amount of oxygen lost to respiration from the dark container. We will have the total, the net primary productivity, or oxygen produced from the green container, and from that we'll be able to calculate gross primary productivity. So here's how we're going to do that. First thing, you and your group are going to get 4 stoppers, 1, 2, 3, 4. These stoppers do have latex in them, so be careful about that if you have any latex allergies. Also, you're going to get a flask that's labeled green, that's not wrapped in aluminum foil, a flask that is labeled tap, for tap water, that is not wrapped in aluminum foil, and then you will pick up a green flask wrapped in aluminum foil and placed in a large 1,000 milliliter beaker. And then you will get a flask wrapped in aluminum foil labeled tap that's also in a 1,000 milliliter beaker. You're going to fill the tap water flasks with tap water from the sink. When you fill them up all the way to the very top, and then so far up to the top that when you place the rubber stopper in it, water is going to spill out over the side. We have paper towels. You can do this over the sink. Just clean up whatever you spill out. Make sure there's no excess oxygen bubbles in the flask itself. So you do that with the flask that's not wrapped in aluminum foil, and then you do the same thing with the flask that is wrapped in aluminum foil labeled tap. And in this case, you're going to put the aluminum foil flask in the beaker, and you're going to fill that beaker up with some water. This is to keep the flask at a similar temperature as the flask without aluminum foil. Next, you're going to fill up the green flask. The green flask, you're going to be filled up. This is water. The water in these jugs are water from our lake. They have a green tint to them because there's a lot of algae in it. And you're going to fill up the flask without aluminum foil the same way you filled up the tap. You fill it all the way to the top, put the rubber stopper in, and then excess water will go out the side and make sure there's no extra air bubbles. And you're going to do the same exact thing with the green flask wrapped in aluminum foil and place it in a water bath as well. Things you're going to be sharing, you're going to have the flask are going to be just for your group, but you're going to be sharing the water from in the jug, the green water in the jug, and you'll also be sharing the tap water. And you will also be sharing this awesome new and improved dissolved oxygen reading kit. Now, after you have all your flasks filled with water, it's time to start sampling the water for dissolved oxygen, measuring the dissolved oxygen in the water. To do that, you're going to fill up this water sampling bottle with whatever sample you're testing at the moment. So I'm going to do this with the tap water at first. So what you'll do is you'll uncork the tap water. You're going to carefully fill up the water sampling bottle all the way to the very top with your water. The goal is to have any air bubbles, so all the way to the very tippy top, all the way. Make sure there's none, so you can spill out even if a little bit spilled out over the edge, that's good. Take the cap, put the cap on there, a little more water might spill out as you tighten the cap on, and then you can begin to start testing your water for dissolved oxygen from the water sampling bottle. I have a video that I shared with you that goes over in very much detail about how to sample using this kit, and also there's instructions on the inside lid of this kit to help you sample. You're going to be sampling dissolved oxygen from each flask. the unwrapped tap flask, the unwrapped green flask, and the wrapped tapped and green flasks. It's very important that after you sample, as soon as you get the water out for the sample, that you refill the water with whatever you took out. So I took out tap water with this one, so I'm going to go to the sink really quick. I'm going to fill it back up all the way to the very top. Make sure there's no air bubbles. Get my stopper that I was using. Watch, when I place the stopper on top of it, water's going to spill over the edge. A little bit of water spilled out, that's okay, I'll wipe it up in a second. And then you're going to let it sit for a while. The unwrapped flasks are going to be going underneath the lamps in the back, and the wrapped flasks are going to be placed away from the lamps and making sure that the aluminum foil stays up all the way around it so we keep them dark. So all they do is respiration and no photosynthesis. You're going to test for dissolved oxygen at 3 different time periods for all 4 of the flasks. You're going to be testing at 0 minutes, at 30 minutes, and then at 60 minutes. You will be recording your observations on a data table. I suggest you record it on kind of a loose sheet of paper and then re-record it into your lab notebooks. After the 60 minutes have passed and after you've recorded all of your data in parts per million, your dissolved oxygen in parts per million, you can then do the calculations, answer the questions, and fill out your lab book in the way that is laid out for you in the syllabus. Other than that, I think that's about it. Good luck, and I'll be around if you have any questions.